Yeah, so welcome everybody to the IPv6 first hop security features on HB switches talk. I'm Christopher, I'm head of the network security at ENW. IPv6 geek, I would call it, and I have included the slide and I was writing down here, so it's maybe better readable for you here. So 7:30 p.m. Starts the dinner. We have the buses which are leaving the PMA at 6:30, and the restaurant name is Hirschgasse. To be fair, I'm born and raised in Heidelberg, but I have no clue where this restaurant is, so I have to take care of myself how to get there when I'm not taking the bus, but I will find my way. So then I would suggest we start first with the agenda. So at the beginning we are doing a short introduction to first hop security in general, as well as the overview of supported first hop security features on HB platforms, specifically for CommWare 5 and CommWare 7, which is the operating system the new HB or H3C switches are running, and we will have a look at what kind of first hop security features we can actually are supported, and how are they configured, and do they work as they should. So then, of course, implementation and behavior of these features. We will see that there are a couple of differences compared to CommWare 5 and CommWare 7. Then, of course, we will have a look at evasion techniques. As you may know, the first hop security features on the Cisco switches can be evaded with fragmentation and extension header, and we will have a look, can we apply the same techniques for these features on the HP world? Then a little bit of implementation advice, and last but not least, the overall conclusion for this talk. If you have any question in between, just raise your hand, please, and I'll try to answer them. So then let's start with the introduction. So first hop security is, at least from my point of view, Cisco established name for various security features in the context of IPv6 found in typical access layer switches. Was initially rolled out in 3 distinct phases on the Cisco side. It's a little bit different on the HP side. But HP, as far as I know, isn't calling these features first hop security features, but just as everybody knows what's about or what first hop security means, I will just name them the first hop security features. So the first one we will have a look at is route advertisement guard. Implements the isolation principle similar to other layer 2 protection mechanisms already deployed in the v4 world. Was specified in RFC 6105 a couple of years ago, and currently in the HB world, what we do have, we have to distinguish here between CommWare 5 and CommWare 7 platforms. Initially in the CommWare 5 release, you do not have a dedicated RA guard feature, but you can achieve a similar behavior with a feature called ND detection. As the name implies, it's a security mechanism for all neighbor discovery related packets, neighbor advertisement, neighbor solicitation, but also for router advertisements. So on CommWare 5 platforms, you do not have a specific RA guard feature like you're used to in the Cisco world, but with the ND detection. HP started to implement a dedicated RA guard feature, starting with CommWare 7 in this special release, so that you have a Cisco-like IPv6 and the RA guard feature on these platforms. So depending on which platform you're running, whether maybe CommWare 7 is already supported and released. I had a hard time convincing this 58 HB switch. I had a hard time to convince him to speak or to run the CommWare 7 image. I got the image from an HP representative, and I tried to update it, but it failed miserably. And then I talked to some other HP support staff, and he asked me, hey, from where did you get this image? It's officially not released from HP. I got it from an HP representative. And you have already uploaded the release notes for this COM 7 image on the public HP site. So I was under the assumption, yeah, that it's already released and I can use it. And your HP employee has given it to me. So it should be supported. But as of right now, this switch is only running COM 5 because I had a dedicated migration guide from COM 5 to 7, and I actually upgraded the RAM. I took off the shelf and removed the RAM and put in total 2 gig. Luckily, they are using SO DIMMs, so I just used the old Lenovo notebook and put in a 2 gig RAM into it, but unfortunately that didn't help either. So we will of course discuss how our AGuard is implemented or configured on COM 7 based platforms, but due to these constraints, I will show a demo, unfortunately only for the COM 5 platform. So as I said, there's a little bit of difference in regards to the behavior and in the configuration of our AGuard. In COM 5, you have to enable this ND detection mechanism or feature globally, and then you have to apply the trust state to a dedicated port where your typical router is connected. Whereas in the Cisco space, you configure this, at least in the light variant, you configure AGuard on ports where you do not want to see these router advertisements. Here in the HP world, you will have to use enable ND detection and then exempt the port where the legitimate router is connected. So another feature or features which are supported on the HP devices is DHCPv6 and ND snooping. Cisco calls it DHCPv6 guards. HP calls it DHCPv6 snooping. They both achieve the same goal to ensure that no one can send from an untrusted port DHCPv6 server packets. And there's in general quite a good support both in COM 5 and COM 7 platforms. Yeah. Pretty similar to the IPv4 world where you have DHCP snooping, provides finer level of granularity than DHCP snooping because you could theoretically specify, okay, what can be inside the DHCPv6 packets, but typically from our point of view that's not necessarily needed because you just configure or you activate DHCPv6 snooping or guard on the respective port or VLAN. Then, of course, ND snooping, same behavior as in the Cisco worlds, is also supported on both COM 5 and COM 7 releases. Must be enabled and is the basis for various other IPv6 first-hop security features. So that, for example, ND detection can work so that the switch knows when I'm sending a false or spoofed neighbor advertisement, that the switch can check the content of the spoofed neighbor advertisement to make a decision, okay, is this a legitimate neighbor advertisement, yes or no? And the basis for all of this is the ND snooping, or is ND snooping because the switch is then building the snooping table internally, and when a neighbor advertisement packet arrives on the switch, he will determine, okay, is the association between IPv6 address and MAC address valid based on the entries in the table. If this is the case, the neighbor advertisement will get permitted. If that's not the case, the neighbor advertisement packet will get dropped. So then we have the ND detection feature, as I said, is responsible for all neighbor discovery related packets, neighbor solicitation, neighbor advertisement, router advertisement. Well, router solicitation, typically not. That's an error on my part on the slides. But for these three, ND detection can be used, and as soon as you activate it on the VLAN, then the route advertisement from your legitimate router will not get forwarded because you have to explicitly configure the trust state on the port where the router is connected. But it can be used to, of course, prevent ND spoofing attacks like in the Cisco world. And another feature which HB implemented is IPv6 source guard. Also supported on CommWare 5 and 7 releases, prevents IPv6 address spoofing from a client connected to a given port. This source guard binding can be either learned dynamically through DHCPv6 snooping, or I can configure it statically on the switch, but the dynamic learned variant is the preferred one, because otherwise you would have, based on the amount of ports and clients you have, quite a lot of configuration you have to do on the switch. So to summarize, on CommWare 5 and 7, as I said, you have in CommWare 5 you have RA guard like functionality, but not with a dedicated RA guard feature, but with the ND detection feature. And as we can see here, DHCPv6 snooping, ND snooping, and IPv6 source guard. These features are both supported on CommWare 5 and CommWare 7 platforms. So let's have a closer look on how to actually configure these features, and do they work as advertised. So my lab setup consists of an HP 5800, which is lying here, running the latest CommWare 5 release, which was available and just released, I think, 1 or 2 weeks ago. I had the typical Cisco router, which is standing here. I have my 2 clients, Innocent Alice and Evil Joe. Evil Joe is just running the latest Kali Linux with Chiron and THC IPv6 installed, just to evaluate, okay, do these features work like advertised or not. So pretty basic setup. All are member in the same VLAN, but this is the simple setup which you see here right in front of me. So, but before, just a word of advice, because I've encountered this problem. Before you're doing anything IPv6 related on the HP switch, you should make sure that IPv6 is enabled. The switch doesn't tell you that you have to enable it. You can configure all these features and of course also ACLs without enabling IPv6. The switch won't tell you you have to do it, but if you forget about it, then you might run into problems that these features might not work as desired, especially in the case for access control list. I had some pretty strange behavior when I started the lab in regards to ACLs until I discovered, okay, maybe I should activate IPv6, and as soon as I've done this, all worked as it should. So, but be aware, and just a word of advice, before you're doing anything IPv6 related, make sure that IPv6 is enabled globally on the switch. So let's have a look at ND detection, the RA guard-like functionality on CommWare 5 platforms. As I already said, CommWare 5 does not have a dedicated RA guard feature. You can implement RA guard-like functionality over the ND detection feature. ND detection must be enabled on a VLAN basis, and the trusted ports where your legitimate router is connected must be exempted from the feature, so that of course your legitimate router advertisements will get transferred or transported to the clients. From a configuration point of view, it's pretty straightforward, nothing too fancy. You just have to enable ND detection on the desired VLAN. In this case, I specified VLAN 245 and just said, okay, I want inside this VLAN, I want to use the IPv6 ND detection feature and enable it. And then the next thing I had to do was exempt the router port from the ND detection feature. Otherwise, the switch would have filtered the legitimate router advertisements, which is, of course, which I didn't want to achieve. So with CommWare 7, as I already said, HP implemented a dedicated RA guard feature where it configures and behaves similar to the Cisco implementation. You define or specify ports, or the ports are assigned either the host or the router role in the context of RA guard. Host role is the equivalent as when you would activate RGAT in the Cisco world. So every router advertisement received over this port will get discarded, and the router role, if the switch receives a router advertisement, it will get just permitted. Pretty straightforward configuration as well. Just on the desired interface where you want to have one or the other role, you just configure IPv6 NDRA guard, the same syntax as in the Cisco world, and just specify the role. Here on Gig 101 router, because my legitimate router is connected there, and all other ports are in the context of our AGAT configured as a host, so that all sent RAs are just discarded from the switch. So what we will do now, we will just configure it, and hopefully the switch is now online. So can you see it? Yes, this looks good. So just to make sure that the right configuration is running. So that's my router uplink. It looks fine. Just want to make sure that I'm receiving RAs. Yeah, that looks good. So, and I should have an IPv6 address. Yes, as you can see here on my Ethernet interface, the router is sending his periodic router advertisements. My client generates 2 addresses, and I have a default gateway, which looks good as it should. And what I would do now is pretty easy configuration. And now, of course, I have to exempt the router. So if it behaves like it should, I should not see any more router advertisements. Let's just wait a couple of seconds. I think I had the interval pretty low, so looks like it's working as expected. So now, of course, we want to exempt the uplink port from the NT detection feature. And we just say, okay, you are a trusted host. And ideally, I should see them again. Yes, as you can see, the next one was sent again after I explicitly configured the trust on the router uplink port. So the first thing we want to test now, okay, does it behave like it should? So what happens when some kind of unauthorized entity just tries to flood the network or send fake route advertisements? For this specific case, I just have my normal Kali Linux. And we are not doing the flood, otherwise I shoot myself in the foot. Let's just start to send the fake router advertisements with a specific prefix and see how it works out. So at least as we can see, the only router advertisements that we receive as of right now are these from the legitimate router. And this should also mirror my configuration. My configuration hasn't changed at all. If I would have received the spoofed router advertisement, I should have now a different prefix in it configured additionally. Just give me 1 sec. Oh, I hate this. So I should have seen 2 addresses generated from this prefix. which I haven't seen, and on the Wireshark output, we see, okay, it seems to work how it should, which isn't not surprisingly, well, not very surprising to be honest, but it's always good to double check, okay, if you implement or activate this feature, does it really work how it's advertised? And in this case, it is working as expected. Unfortunately, I cannot show you the RA-guard feature on the ChromeOS 7 platforms. As I've already said, I had quite a lot of trouble to update the switch to ChromeOS 7. Here we go. So, pretty easy to configure. It's doing what it's supposed to do. And in ChromeOS 7, as already said, we have a dedicated RA-guard feature. You can either use it in two variants, either the simple variant where you just define the role, host or router, or like in the Cisco world, you can define policies where you can specify, okay, which content can be or is allowed to be in the router advertisements. As you can see here, this is just one example RA-guard policy definition. You configure the policy, and you can say, okay, just allow a router advertisement when the router preference is set to high. If the managed flag is set, and if the prefix inside the router advertisements matches in pre-configured ACL, so you cannot specify the prefix just out of the box. You have to specify an ACL before, and then have to apply the ACL here in this context. Same procedure here. If match ACL 2001, this configuration parameter defines, okay, which link local address is allowed to send the router advertisements, and you can't just say match FE80 colon 1. You have to specify FE80 colon 1 in ACL, and then have to apply the ACL inside the RA-guard policy. And they have to be in separate ACLs. And then just attach the policy to a VLAN so that it gets implemented, and to verify the configuration of the RA-guard policy, just say display IPv6 in the RA-guard policy, the way you just get all the items you configured. We can see here our policy from which source address or which source addresses are allowed to configure to send router advertisements, which flags have to be set, what's the hop limit, what's the prefix, and to which VLAN it is actually applied. So basically, it's kind of similar to the Cisco implementation, but here in this case, in the HP case, you have to work here with ACLs, which is a little bit cumbersome, but not that much of an issue, to be honest. So the next feature is ND snooping. You do have the possibility to define, okay, do I want to enable ND snooping for link local and or global addresses? We have to specify this globally once. As you can see here, IPv6 ND snooping enable for, in this case, link local addresses and global addresses, and then in order to so that ND snooping works as desired, we have to apply the ND detection feature so that the switch can evaluate the neighbor advertisements packet to decide, okay, is this a packet with a valid association between IPv6 address and MAC address or not. So pretty easy to set up as well. Sorry?
What happens to the other scopes?
Well, they are just not implemented, or the ND detection feature will not work for these scopes, at least for neighbor advertisement or neighbor solicitation packets. So But actually, I haven't tested what is the exact definition of HP for global address. Maybe there is, maybe they also included unique local addresses, but honestly, I haven't tested it, so I'm not sure. And I couldn't find anything. It could be, but I couldn't find anything in the documentation guide about it. And to be fair and to be honest, I haven't checked it. So as of right now, I don't know. Maybe maybe unique local addresses are included, or maybe not. But that's a good point. I need to double check that.
If global is anything but local and local goes extra, that would still be 100%, which would be okay.
Yes, which would be okay. Absolutely, definitely. So. So, and well, yeah, this one is also not helpful. And link, yeah. So, I mean, I already activated it. So let's just do a little bit of pings. This looks good. ETH0. This looks fine. So, END detection feature is now enabled. Let's have a look. Okay, what happens when I try to send spoofed neighbor advertisements? So for this one, I just use the fake advertise 6 module of THC. So what do we want to do? We want to set the override flag. We want to be, no, we don't want to be a router this time. And then we say, okay, we want to send a fake advertise more FE80 : 1. Where do we want to send it? Let's just send it to the link local all nodes address and see how it behaves. Yeah. Oh, that's maybe the wrong Wireshark instance. Then, good point. Oh, I hate the small resolution. So I'm sending them out, which is fine. So the question is, do they arrive here on my local client? And as it seems they do. No, they do. No, that are only the, oh, wrong filter. Sorry, but the resolution is, do not get anything on one. So, but at least what we can see is that we don't see the spoofed neighbor advertisements which are sent from the client or from the attacker in this scenario. As we can see here, he's just sending them periodically, these neighbor advertisements. And the switch is just discarding the packets. But what is interesting that there's actually no indication that something goes wrong. In one specific scenario, I had to explicitly enable the debugging for this feature for actually to show so that these packets show up. So from a visibility point of view, because if we have a look, so statistics. What we can see here, yeah, okay, there are some dropped packets, but if we have a look at the log, yeah, wrong. In the log buffer, we see that we don't see that much. The only things we see here in the local buffer is, yeah, that I configured these features. They seem to work. The statistics imply that there are dropped packets, but you do not have kind of good visibility in regards to these packets because, yeah, I mean, of course, you could query the counter, but there's no syslog entry or anything indicating that someone is trying to send spoofed neighbor advertisements, for example. But at least it's working as expected, which is a good thing. So another feature, DHCPv6 snooping, as already said, is implemented or is supported on both CommWare 5 and CommWare 7 platforms to prevent rogue DHCPv6 servers. Same configuration wise, similar to the other features. We have to enable IPv6 DHCP snooping globally, and then like DND detection, we have to exempt the trusted or legitimate port where the DHCPv6 server is connected. We have to trust this port, so exempt it from the DHCPv6 snooping feature, so that the legitimate DHCPv6 server can serve the clients with either addresses or DNS server or other DHCPv6 options. Beginning with CommWare release 7, and this specific release, HP also implemented logging capabilities for DHCPv6 snooping, so that you can at least provide some form of visibility when someone tries to, or when someone sends DHCPv6 server packets, that it at least gets logged, but currently only available on CommWare 7 platforms. Unfortunately, not on my CommWare 5 based system. So, and then we have, of course, IPv6 SourceGuard. SourceGuard can be used, as I already said, to prevent or to IPv6 address spoofing. And the decision whether an IPv6 address is spoofed or not is based on the snooping, the ND snooping entries, the DHCP snooping entries, or based on static configured bindings on the switch. So packet comes in, the switch has to determine based on these three sources whether the source IPv6 address is valid or not. If it's not valid, of course, the packet gets discarded. Otherwise, it will get forwarded, of course. Configuration-wise, pretty simple. We just have to activate it on the port. In this case, IPv6 verify source. And if you really want to configure static bindings, then you have to do it globally with the IPv6 source binding, IPv6 address, and the MAC address, so that the switch knows, okay, on this port, that this static binding is active and can check against this binding. So these are the general features which are supported on the HP platforms. And as we've seen, they work as expected, to be honest. So the next thing I had to look at it was, okay, what about the evasion techniques? Can I somehow evade these configured features? And if so, how can I achieve that? As you may know, in the Cisco world, it is currently possible to evade them with extension header and fragmentation. And in this scenario, I wanted to answer the question for the HP world. Okay, can I somehow circumvent this configured feature? So, what I quickly discovered that it isn't necessary that I fragment the packet in any case, as long as I make sure that the packet has at least 3 extension headers. Fragmentation isn't necessary. When the packet has more or at least 3 extension headers, I could easily evade the configured RA guard or the ND detection feature. And fragmentation for this was not necessary. And to do the evasion, I've used Chiron, where Rafael and Antonius will have a workshop tomorrow with some advanced attack techniques with extension header. And I used Chiron, this Python-based tool, where I just say, yeah, please, Chiron, send a router advertisement. Please just randomize the prefixes inside the router advertisements and put on some extension headers. These numbers here are the extension header numbers. 0 is the hop-by-hop header. And then I said, okay, please insert a hop-by-hop header and 3 destination options header and send them out over ETH0. And with that, it was possible to circumvent the RA guard feature, and without the need for fragmentation at all. So, coming back to that. No, I don't want Iceweasel. No. Sorry? Thanks, yeah. Where is it? So, what I will do now, just copy and paste it. Hopefully it works. So, it is actually started. So let's have a look at the Wireshark here on the attacker machine to verify that it's actually sending the packets. And as we can see here, yes, it is doing it with a randomized prefix. And when we have a look at the IPv6 header, we see the mentioned hop-by-hop header and the 3 destination options header, which are used for this evasion. And so let's have a look at my client locally. So, and as we can see, they are also arriving on my local client. Just by using 3 extension headers. So it doesn't matter what kind of extension header. It could be 3 hop-by-hop, could be 3 destination option headers. So, but the amount of extension header must be equal or greater than 3. Then you can evade it. So let me check. These are the route advertisements sent with the prefix information. So, but apparently, for whatever reason, yesterday it just worked great. But as we can see, My client still has only one IPv6 address or two from the legitimate client router configured. So I'm honestly not sure where it comes from, as it worked yesterday, but the demo gods were apparently not with me. So, in any case, what we at least have seen that with the 3 extension header, it can be circumvented. To be honest, I have to double check why my client is not processing these router advertisements as he has done it yesterday. And this was discovered, I think, 1 or 2 years ago. So HB tried to implement a countermeasure to prevent that kind of the usage of these extension header. What have they done? No, that was the wrong button. So what have they done? They have implemented a new configuration knob. They have implemented a new configuration of IPv6 option drop enable, which you enable globally once on the HP switch. And the HP behaves the following. Any packet which has more than 2 extension headers will always get dropped. And any packets which contain the hop-by-hop header will also be dropped. And as soon as I activated this option, the extension header-based evasion did not work anymore. But of course, there are more ways to evade such features than just extension headers. So I was quite curious, and with the help of Raphael, we tried a couple of things to see, okay, can we maybe circumvent this mitigating technique? But as soon as let me just enable it. Yeah, wrong system. So I have enabled it globally, and ideally yes, as you can see, as soon as I have configured this option, the router advertisements are not seen anymore on my legitimate client. Of course, Chiron is still sending them, but because it meets the criteria that it's more than 2 extension header, it isn't, the switch just drops it. But also in this case, no logging capabilities, or so that you have a kind of visibility that there's something happening at all. And so we came back to the drawing board. Okay, is there any possibility to circumvent this feature? And we really tried a lot of things. I know that's pretty hard to read. So these are all the tests we have done in regards to various combination of extension headers, various fragmentation-based packets. But as you can see, I mean, we are not done yet. Of course, we haven't tested all possible variants as of right now. But as you can see, most of them were not working. The only time the RA got through when we just used a fake extension header, so an extension header which doesn't exist, so with an invalid next hop value. So then the packet got through, but my client didn't process the router advertisement, and so I didn't have another default gateway. And as you can see here, all of these tests, if you are more interested in more technical depth, what they all mean, please visit the Chiron workshop tomorrow, where Antonius and Raphael will provide details with Chiron and how to do several evasions. But as we can see here, we have tried quite a lot of things, but unfortunately, or fortunately, depending on the point of view, we weren't able to circumvent this feature as of right now. As I've said, we haven't tested all possible variants, but as of right now, it looks quite good from an HP perspective. And these are the other tests we have performed, and it's just not working. The only time it's working is when we are using a fake extension header. Then the router advertisement gets through, but not processed by the host because he does not know what extension header it is, and just discards the packet. Yeah, so as you can see, quite a lot of stuff has been done, but as of right now, we weren't able to circumvent the IPv6 first hop security features as soon as this IPv6 option drop enable was configured. Maybe we will find a way in the future, but as of right now, it's not. We weren't able to circumvent these features. So, from an implementation advice, so typically on the HP side, RA guard is a recommendation, but only in the light variant. So, from our point of view, no need to configure a policy for that. The normal version with the device role host and router is sufficient from our perspective. The IPv6 snooping as well in the light variant. ND detection with COMWare 5 products to have RA guard functionality, and make sure that you enable this option on your HP switches to make sure that the evasion techniques which we use and were successful do not work anymore. And as I said, as of right now, we unfortunately weren't able to circumvent the configured first hop security features.
Is there any feature like that on Cisco?
Not that I am aware of. Maybe Eric, you can comment on that better, but I'm not aware of any feature.
Dropping packets like this, no, not on iOS routers. The only thing is the undetermined transport.
Yes, in the ACL. Yeah.
And that's on the global config?
No, that's just an.
Not on iOS means on NXS there is?
No, I don't know.
Yeah, but I'm not aware of any similar feature in the Cisco world in general. I think I did 2 hours research to answer that question, but I couldn't find because I couldn't find anything in the Cisco space which would be like this optional. What I still have to test how the HP switch behaves in general with fragmentation. Maybe they just dropped all fragments because of the router advertisements, or they are dropping all fragments in general, which would be bad from an IPv6 point of view, but I need to double check that. So, and in the Cisco world, I'm not aware of any feature similar to the HP implementation. So, to summarize, overall good support of these first hop security features on COMWare 5 and 7 platforms. As of right now, as I said, we weren't able to circumvent the FAH features as long as the IPv6 option drop enable is configured. But as I've already said, we haven't tested all variants of it because there are just too many of them. But we will do further lab testing, and maybe we can evade these features. And overall, the implementation seems to be pretty solid. They are a little bit on the light side regarding logging capabilities, but at least in COMWare 7, they seem to implement more and more logging capabilities in the newer releases, for example, for the IPv6 snooping. So if you're running COMWare 7 on a pretty recent release, there may be more logging capabilities than as of right now in this COMWare 5-based platform.
And that's all the HPE gear. How about the Aruba gear that's now bought
I can't comment on it. We haven't tested it. So this is all. This only applies for CommWare-based platforms, and I don't think that CommWare is running on the Aruba-based gear. I don't know. So I can't comment on that because we haven't tested it because we do not have any device, but maybe worth to get one and do it again for these devices.
I've heard that the HP variant shall rather go down and Aruba shall take over entire network. Yeah, but HP bought Aruba, not only for the wireless, but also for the wired.
Well, from an HP perspective, I don't know if it would make sense after they acquired 3Com and H3C to now integrate their Aruba switching or routing line into their product portfolio, running different kind of network operating systems. I mean, they could technically do it, but I would assume they're doing it primarily for the wireless gear, would be my assumption without any details I know. So
one of the rumors I've heard is that buying Aruba did cause them to commit that all the networking together was now under the Aruba hat.
okay.
Okay, the Aruba management now takes over the entire
Networking part of HP.
and that's
Okay.
the deal.
The small switches from HP were renamed to Aruba. Only the small switches.
Okay.
Okay, interesting. Well, we'll see how it develops. But thanks for the info. Wasn't aware of that. Yeah, and overall, the implementation seems to be pretty solid. What we can say, with the minor exception that you're pretty light on the logging capabilities. So, and that's it. I think I'm a little bit faster than intended. Yeah, it's 16:35, but then you have a couple of more minutes to take a coffee, go to your hotel room. Yeah, thanks for your time. Then hopefully we'll see us tonight at the dinner, and then have a great evening, and thanks for your attention.